Howdy. In this series, we're using AI to help us learn Elixir. We're speedrunning the Elixir track on exercism.org using AI as our partner and trainer. Today's exercise is Kitchen Calculator. We're going to learn about tuples and getting more practice with pattern matching. We're leveraging NotebookLM for a presentation on the exercise and a quiz. We'll get Copilot to collate the instructions into the source code so that we can focus on the task at hand. The Kitchen Calculator exercise is about tuples and pattern matching. Tuples are a primary data structure in Elixir. They hold a fixed number of data values. The length is fixed because a tuple is immutable, meaning once you've set it up, you cannot change it. The order of the elements in the tuple is preserved, so you can either pattern match to get a value out of it, or you can use the elem function to pull out an indexed version. Indexes in tuples are zero-based, so the value 1 here is index 0, the A atom is index 1, and hello is index 2. The NotebookLM presentation on the Kitchen Calculator is linked in the description below. Let's take the Elixir quiz to make sure we're ready to go with the concepts needed for this exercise. In Elixir, what is the primary reason tuples are considered efficient for read-intensive operations? Well, they can't be modified, so it's not A. They don't use named elements, so it's not B. They are always stored in a sorted order. That's true, but I think they're looking for accessing an element by its index is a constant time operation. How would you correctly access the string hello from this tuple? Well, they're asking about indexing into a tuple. They're zero-based, so 0, 1, 2. So we're looking for the elem function with the index of 2. According to the source, what is the fundamental role of the equal operator in idiomatic Elixir code? Equals is the matching function in Elixir. So it's not typecasting, it's not assignment, it's the match operator. That's true. What happens if an Elixir function is called with arguments that do not match any of the defined function clauses? It's not a compile error, it's not a match error, it is a function clause error. What is the primary purpose of the Kitchen Calculator get volume function as described in the exercise? That function, they're looking for you to just pull out the volume piece from the tuple. So we are looking to return the numeric component from the volume pair tuple. Using the provided conversion chart, what is the correct conversion of fluid ounces to milliliters? Well, let's see here. They are looking for fluid ounces. There are 30 milliliters. So we have 4 of those, so we have 120 milliliters. In the context of the Kitchen Calculator convert function, what is the beneficial use of milliliters as an intermediate unit? Well, the whole point of this exercise is to be able to convert from any unit of measure into milliliters and then from milliliters back out. So we're looking for something that talks about a common intermediary format. And that looks like C. What is the expected output from milliliters given 30 and looking for a tablespoon? A tablespoon has 15 milliliters. So that would be 2 tablespoons. Pattern matching. What is the role of the underscore character? That says, hey, Elixir, there's going to be something there, but we don't need it, so don't bind to it. And that would be, right, it doesn't have anything to do with the data type, so it's not a private notion, so it's like other languages, so it's not C. And that it's not an optional, that's the double backslash, and that's not something in tuples. So we need the placeholder. And the last one. If you are implementing 2 millimeter function and the Elixir feature recommended for handling different units like cup and teaspoon, what is it? Functional clauses with pattern matching on arguments. That sounds pretty spot on for Elixir. Protocols. We have not gotten to protocols yet. Map is a different kind of data structure in Elixir, also very common. We'll get to that later. And a single case statement. Well, we saw the conned statement in previous exercises, but that's also not what they're looking for. They're looking for a. All right, on to the exercise. I mentioned in the introduction that we were going to use a new prompt to bring the instructions into the source code so that we can stay focused to the task at hand. I've kicked off that prompt. It says, this is an exercise from exercism.org. I'm learning how to code in Elixir. Do not alter the function definitions or content provided as starting points for the exercise. That's because I don't want it to help, provide the answers. Help me by assembling the relevant information as documentation into the source file as function documentation. Gather the instructions for each function from the README, and then include IEX-based examples derived from the test file. I'll explain those in a second. So here we see Copilot working on that prompt. The green areas here are the code that Copilot has added. And so we see that it's adding the documentation as it goes. And once it's finished and we accept them, the formatting will get better. So let's keep the results. Let's take a look at what we have. I'm going to dismiss chat for the moment. There we are. So this says it's the Kitchen calculator exercise. It's a helper function for working with volume pair tuples. This is pretty much the information straight out of the instructions. But then here for this first get volume document, it says return the numeric component from the volume pair tuple. The volume pair tuple is in the unit value, where unit is either milliliters, cups, ounces, so on and so forth. And here's the IEX example. We'll see more of this in later exercises, but this is a very standard way to document how you use a function in Elixir, and it can also be used to test your functions in Elixir. So what we want here is we want to match the volume pair. We know that it's going to be unit and volume. And then we only want to return the volume. And we can take this one step further. You see how VS Code is telling us, hey, unit's unused. And we remember that we can prefix it with an underscore to say, hold this as a placeholder, but there's no need to bind the value because we're not going to use it. So we could now run our tests. And we see that it passed. All right, next section. Convert a volume pair to milliliters. So use this chart. So it gives us the conversions here. It wants a millimeter value tuple back. And so here's an example. When 2 millimeter is called with a cup 2.5 tuple, it wants milliliters and 600 back. So what we're going to say here is, for example, might as well do the cup one. And whatever volume is passed to us, I'm going to also do these as one-line versions because they are short. All right, so that's cup. We need fluid ounce. Fluid ounces by 30, teaspoon by 5, tablespoon by 15. I wonder if that's all. So let's try. We'll run our tests and see. Oh, it also wants milliliter, which of course makes sense. So we'll add one more. And of course that just is itself. Convert the millimeter volume pair to the target unit. So given a measurement tuple of millimeters and a volume, return that as cups, so 5.5 cups. So this is the same as before, but we're going to invert it. So we're going to match millimeter and volume. We want, in this case, they're requesting cups, and so we know to divide the volume by 240. And it is providing the rest of these for us, and that looks right. And those pass. Lastly, we are doing conversion. So given a starting tuple, convert that to the target unit of measure. This is where we get to pull in our pipes. So we can say, let us take the volume pair. Yeah, it's perfect. Take the volume pair, convert it to milliliters, and then take that and convert it from milliliters into the unit that's being passed in. Perfect. So let's make sure it passes the test. Mix test. There we have it. So in this case, we used Copilot to bring in the instructions so that we could more readily follow through what the functions needed to do. And we used the autocomplete IntelliSense to let it do a bunch of the routine implementations. In the guessing game, we used Copilot Chat to run our tests. Here, we use Copilot to bring information into documentation. Not only did that make solving the exercise easier, but also results in a better solution. Check out the NotebookLM presentation video for an excellent overview of this exercise, but give this video a like to let me know it was helpful to you or that you simply enjoyed it. Join me next time for the high school sweetheart exercise where we learn about strings and are formally introduced to the pipe operator.